Welcome back, everyone. Today we continue on in our Intro to Recursion series, and we're going to be talking about how to sum the first n elements in an array. And we'll talk about more about what that means here in a second. All right, so some things that I'm going to assume about you is that you have a basic understanding of JavaScript syntax, and that you've either been following along in the Intro to Recursion series, or you have a fuzzy idea of what recursion means already. And that's it. So this is actually a problem on Free Code Camp. And if you've ever been on their website, you may have already seen it. But if not, let's go ahead and take a look at it now. All right, so we have a lot of things on the screen here, but on the left-hand side, you can see this problem statement. And then on the right-hand side, we have the opportunity to write some code. So I'm going to elide over this. This is mostly setup. I do encourage you to read it, though, and try to solve it on your own if you haven't already. But here's the problem. Write a recursive function called sum. It will take an array of numbers. It's also going to take a number that we'll call n, and it's going to return the sum of the first n elements of an array. So you see down here, they say if you call sum with an array of 1 in it, and you pass in 0 as n, that should be 0, and then they give you a few more examples. And you can see that we have the opportunity to run some tests, and we'll do that a little bit later, but for right now, let's skip back and explain the problem in more detail. When solving recursive functions, I like to keep a few things in my head. The first of which being the acronym BAR: base case, action, and recursion. We've talked about it in previous videos, and we're going to be discussing it again. The next thing is the concept of moving through an array, or really any data structure, but we're talking about arrays right now. So this concept is very important because we have to think about how we might approach this. The next thing is that we have to remember a recursive function can't actually finish, it can't return until every subsequent recursive call is finished, right? That's an important concept to know moving forward. So I did a video in the Intro to Reduce series called Implementing or Building Reduce Using Recursion, I think the name of it was. And we talked about some mental models about how to move through an array. So the first one was passing the tail. And if you remember, or if you've watched the video, we talked about the idea that passing in a tail of a tail of a tail in a recursive call will help us move toward our base case. The next thing we talked about was using an incrementer. And here we're actually going to talk about using a decrementer. And this is important because remember, we have to move toward our base case. So in this example, we're going to talk about using a decrementer to move backward through the array. Now, because addition is commutative, the order in which we add the elements doesn't actually matter. So that's going to be very helpful for us because we're going to move backward through the array. All right, so when I'm approaching any problem, the first thing I usually do is stub out the function, right? And I write out some pseudocode. And this is a good way to kind of get the big steps that you know you're going to need to tackle. And this way, the problem doesn't seem so big, right? You don't see everything at once. You just see the pieces that you need to do next. It also gives you sort of a psychological win, right? If you make small wins, you actually feel like there's some progress, and it boosts your confidence up. As you can see here, we've went ahead and written out the base case, action, and recursion, and we'll go ahead and fill those in accordingly. Now, before we actually fill everything in, let's think about if we called this function, and something I like to do is think about calling a function with the simplest input. Now, the simplest input here would really be an empty array and the number 0. But I wanted to start with an array of 1 and then pass in 0 to show you that if we called this function with 0 in an array of 1, we would get 0 back. Because the first 0 elements are no elements. If you pass in 0, you're really saying, give me the sum of the first 0 elements. So this is actually our base case, right? If you pass in 0, or if through some subsequent recursive call, you pass in 0 as n, well, we're actually going to return 0 because, no elements added to no elements is going to give you 0 back. Now, what is our action? Well, the way I like to think about this is, what is the purpose of the function? Well, it's going to be addition. We're going to be adding elements together. So if you see down here below, we're going to use this example all throughout the rest of the video. We're calling sum with an array of 2, 3, 4, and 5, and we're passing in 3 as the variable n. and we get 9 back. So the first thing we need to do is we need to find the element that we're on currently and add it to something. And so we can use n to find the index of the current element. Now you might ask, why do we have to subtract 1 from n? Well, it's because arrays are zero-based indexed, and this is a problem that will pop its head up at the ugliest of times, and people forget about it. Senior, junior devs, it doesn't matter. But a way to think about this is, if you want the third element, right, you really just want the element with the index of 2. So when we pass 3 as n, 4 is going to be our first element. Its index is n minus 1, and that gives us 2. And you can see over here, if you follow my big old cursor there, that if we start at the first element in the array, that's going to be 0-based index, right? So you'll have 0, 1, and 2, right? And that gives us 4. So going back to the question, right, we need to add that element that we're on to the sum of the elements before it. So now the question becomes, how do we actually move through the array, backward especially? Well, we can use our parameter n. So this is how we actually move backward through the array. We can subtract 1 from n. And as n is decremented, so does our index in the array. So you can see when we pass in 3, we're going to start at 4 because that has the index of 3 minus 1, which is 2. If you subtract 1 from 2, you get 1. And if you subtract 1 from 1, you get 0. And so we keep moving backward through the array, adding every element. Now, in previous videos, especially the one where we reverse printed an array, we talked about the call stack. And that's very important to understand how that works moving forward. So let's watch the stack wind and unwind as we call this function. Okay, so you can see here that we have the body of this function as the first time that this is called. So this is, remember, a function when it's called, it creates a box, right? It creates a context, and it's going to remember everything that you called it with and everything that went on inside. So that's important to remember going forward. Okay, so this is our first call. So we called the function with 3 and an array with 2, 3, 4, and 5. So let's look at our base case. We do not meet it. And so we're going to find the element that we're on, and we'll find 4, because remember, 3 minus 1 is going to give us 2, and 4 is at the index of 2. So we're going to take 4, and we're going to add that to the sum of the first 2 elements in the array, or 2 and 3. But remember, that creates a new box. This calling of the function creates another box. And this whole function can't actually finish or terminate until every subsequent recursive call is done. So again, 4 plus the sum of the first 2 elements. That creates another box. All right, so now n is going to be 2, right? We look at our base case. We do not meet it. And so we take the element that we're on, and we can figure that out based on n. It's going to be 3. So we say 3 plus the sum of the first 1 elements, which is just going to be 2. That creates a new box. Remember, this function cannot terminate until this function call actually finishes. So that creates a new box. So we have n is equal to 1. We do not meet our base case. We're going to find the element that we're on, which is going to be the element at the index of 0. So that's going to give us 2 down here. So we'll say 2 plus the sum of the first 0 elements. Now, that creates a new box. And remember, we said that the first 0 elements is like saying no elements. And so we actually meet our base case. And so now we're going to return 0. Well, this whole function call gets popped off the stack, and we're going to unwind. So we're going to return to the previous function invocation, and that 0 is going to be carried over. And we're going to add it to the element that we were on in that previous function invocation, which is 2. So 2 plus 0, well, it gives us 2. So now we can actually return from this function. This whole thing gets popped off the stack. We return back to the previous invocation. Our carry, or our accumulated value, is carried over. That's 2. We're going to add it to the element that we were on previously in this function call, which is 3, and that gives us 5. That gets popped off the stack. This can be released. So we unwind. We go to the very first time that we called this function, right? And the carryover, or our accumulated value of 5, comes back. We add that to the element that we were on the first time we called this function, which is 4, and 4 plus 5 will give us 9. All right, so here's another visual for you, and I like to call it expansion. All right, I'm sure we're all refreshed on polynomials from school. Yeah, I don't remember that either, but this is actually kind of like that. And because we can take our recursive calls and expand them. So what I've done here is I removed the rest of the function, and hopefully this kind of declutters everything and looks a little bit cleaner. But the first time we call this function with the array of 2, 3, 4, and 5, and we pass in 3 as n, we're going to add 4 here to the sum of the rest of the numbers. And that can actually be expanded. We can expand this whole expression to this, right? So we say 4 plus 3 plus the sum of all the numbers that preceded it. And this can be expanded. And you can see where this is going, right? We have 4 plus 3 plus 2 plus some expression. Well, this whole thing can be expanded. And since we have 0 as being passed in as n here, we know that that's going to return 0. So the full expression that's expanded will give us 4 plus 3 plus 2 plus 0, and that'll give us 9. All right, so now it's time to actually run our tests. All right, so I've already went ahead and written in the code for this, as you can see on the right-hand side. So let's go ahead and run all of our tests. Nice. Okay, so very good. We've passed all the tests here. Now, it's totally okay if you're still stuck. That's fine. Here are some ways that you can help yourself moving forward. The first being just place log statements everywhere. I mean, honestly, this is something that everyone does. If you're not seeing your output, sometimes it's hard to keep the little bits in your head as you move through every function call. The next thing is use the simplest examples that you can think of first, and then move towards more complex examples. Sometimes by comparing the differences between your inputs will give you an intuition of what's going on. The next thing is question each line. Go through the function, write it out yourself by hand. Each line, make sure you understand what's going on. And lastly, teach it to a rubber duck. I mean, it could be a real person, it could be a real duck for all I care, but as long as there is someone in front of you, either real or imagined, it's going to help. I've probably built up more intuition for problem solving by trying to teach others than I ever would have done just trying to understand the problem myself. And that's it. So if you liked the video, leave me a comment below. And if you didn't, well, tell me about that too. And don't be afraid to hit the like, subscribe, bell icon, and any other buttons that you can hit on the page. And I'll see you next time. Thanks.